There's people on the board. Okay, so today we're going to be working with square roots and cube roots. And there's a benefit to these, guys. Okay, you need to put this away, and you need to grab your notes. Okay. So, can you put that away, Quinn, please? You should be using a calculator. It's part of the course requirement. You need to get a graphing one, okay? Yeah, it's part of the course requirement is to have a graphing calculator. So make sure you all have them. They're going to be really helpful. Make sure you have, if you have an 89, does anyone have a T89 in this room? Because those will not be approved for radicals for sure. It's not an approved calculator, but some of you, 84 is perfect. Okay, so we need to know radicals are great because the reason why we want to work with radicals is they're exact values. Okay, if we're doing lots of mathematics, we want to always work with exact values. Yeah. So if you have something like the square root of 4, well, what does that equal to? Square root of 4, what does that equal to? 2. Yeah, that's what you said. Okay, good. So if we can take the square root of it, and it's going to give us a rational number, we're going to take the square root of it. But sometimes, like square root of 3, if I take the square root of that, will it give me a rational number? No. So it's in our best interest to just write the square root of 3 instead of writing the rational number, irrational number, thank you, of 1.73. But that actually is going to go on forever. Okay, so we want to leave it as an exact value, and you're going to use radicals over and over and over again. It's a number, right? It's how we write numbers. It's how we write them as an exact value when it's an irrational number. Okay, because we want to work with exact. So we're going to learn how to work with radicals. We're going to do specifically 2 things. We're going to learn about a mixed radical and entire radical and how to switch back and forth. Next year, you're going to learn how to add radicals, subtract, multiply, divide radicals. You're going to take it to a whole nother level. Okay? And you're going to use radicals not in just working with numbers, but also it has a big component to trigonometry. Very big component to trigonometry. So you got to be able to work with it with radicals. All right. So this concept here should go on your study sheet. It's really important. If you have 2 radicals, they have to have the same index. Does everyone remember what the index is? Index. Yeah, it's this little number that would go above this, the radical symbol. If we don't see an index, what is the index? 2 for square root. 2. Yeah? So these are radicals, okay? These are all radicals. When we have a square root, it's a name for a radical. Okay, like 4 root 3, this is a radical. So when I talk about radicals, that's what I'm talking about. Okay, something with a square root in it. That's a radical. Or it could be a cube root or a 4th root. So this rule right here is really the basis of our lesson today. The square root of a times b equals root a times root b. If they have the same index, we're multiplying our radicals, we can actually put them all under one square root. So root 2 times root 2, you could also write that as square root of 2 times 2, or square root of 4, which is 2.
It kind of looks like 2 minus 2.
That should be multiplication, sorry. And that makes sense because really, if you're multiplying square root 2 by itself, whenever we multiply something by itself, what is that? What are we doing? We're squaring it. And squaring is the opposite of square rooting. They cancel each other out. Right? When you had a squared equals a squared plus b squared equals c squared, and you wanted to get rid of the square, you took the square root. They're opposite of each other. And so that makes sense that when you square the square root of 2, it just equals 2. They cancel each other out, the square and the square root. Okay, so rewrite root 24 as a product of 2 radicals, one of which is a perfect square. So here, root 24 is called an entire radical. Why do you think it's called an entire radical? Compared to the mixed radical. What? There's no, the coefficient is just 1, right? So it has a coefficient of 1. What's the coefficient? Coefficient. What's a coefficient? No. In this one, it's 2, right? So here, if there's nothing written, it's a 1. It's what's in front of it, the number in front of the radical. So that's why I said it has a coefficient of 1. So really, do we have to write 1 times root 24? No. Root 2 to root 6 is called a mixed radical. Why is it called a mixed radical? Has a coefficient other than 1. Other than 1. Okay? So do you see the difference between a mixed and an entire? That's the difference. Now, which one do you think is most simplified? The root 24 or 2 root 6? Ah, you're wrong. Okay, the most simplified is always going to be a mixed radical. So mixed radicals are always the most simplified form. Okay, are always most simplified. And they're a radical with a coefficient. We kind of already wrote that up here, so I don't know if we need to write it again. Okay, so if we have an entire radical and ask us to simplify an entire radical, we're actually going to change it to a mixed radical. The only benefit of an entire radical is ordering. So if you have root 15 and root 17, which is bigger? Yeah, root 17. It's obvious, right? You can obviously see which one's bigger. We can order who's larger than who. Is it easy to tell who's bigger, 2 root 3 or 3 root 4? No, we'd have to type that into our calculator. So that's the only benefit of being an entire radical. I think that'll be better. Okay, so example. So today what we're going to do is we're going to convert. In our examples, we're going to learn how to convert from, what type of radical is that? A mixed radical. So convert from a mixed to an entire radical. That's what we're going to do. Okay? So, if we want to convert from a mixed to an entire radical, we want to use this rule. We want to use that root A times root B equals root A times B. That's what we want to do. So right now, we only have one radical. We want to change 5 into a radical. So we need to ask ourselves, square root of what equals 5? 25. How did you get that? What's an easy way to get that? 5 times 5. So to bring something into a radical, we have to square it if it's a square root. So root 25 times root 7. And so now that we have a radical times a radical, what can we do? Using this. Multiply them. We can put them under 1 square root. 25 times 7. What does that equal if you have 7 quarters? $175. Quarters are always easier to think about when you have money. I don't know. Okay, so in order to bring this underneath a square root, the 5, we had to square the 5. So then we can go 25 times 7. All right, so let's try another one. 25 times 7? Oh, don't put the square root symbol in. Don't type in, just multiply the numbers because we want to leave it as an exact value. So you wouldn't type in root 25 times root 7 because that is just giving you the decimal. the irrational number. Actually, I should close my brackets before I open up another radical. Okay, there we go. So that's probably what you were getting, right? Yeah, that's what this is equal to. And what's really cool about this is you can always check your work. I can type in 5 root 7. It gives me 13.28, and I can type in my answer. And are they the same? They should be. We're just changing the form. We're just changing how it looks. We're just simplifying. It's the exact same thing, so we can easily check our work after, which is bonus for tests. Okay, so if I want to change 1/2 to be under a radical, what do we have to do to 1/2? Square it. So 1/2, if you're going to square a fraction, it has to be in brackets so that you square the whole fraction. And how do I change that back to a fraction? It's a quarter. Yeah, math, enter, enter. So to bring the 1/2 underneath the square root, we have to square it. So 1/4. So root 1/4 times root 10. Now that they're both square roots, can we put them under 1 square root? Yeah. So 1/4 times 10. So we don't type in the radical, we just type in the numbers. 1/4 times 10. And then 2.5, but we want to write it as a fraction. Math, enter, enter. Root 5 over 2. Okay. Okay, how do I put 4.2 under a square root? Because the question was given in fraction form. And it's always, if we're simplifying something, it is always, like, we don't want decimals. 4.2, we could put in a fraction, but we don't have to just yet. We want to put under square root. Could we just go straight to squaring it? Yeah. So we're going to square 4.2. So I'm going to write an extra step in there so we can see that you're squaring 4.2 to put it under a square root. 17.64. We'll leave it as a decimal for now. Like this one started with a decimal. We can make it a fraction at the end if we'd like. Okay. So now that we have root 17.64 times root 18, put it all underneath the same. Times 18. So what are you going to type in your calculator? 17.64 times 18. And if we want to change that to a fraction, math, enter, enter. So we could root 317.52, or what is that? That's going to be ugly, isn't it? 8 over 25. A rational number. Yeah, you're right. Okay, now usually I won't give you problems with decimals. They'll usually be fractions or whole numbers. But I just thought I'd throw in an example like that. Okay, what do you think you do when you have a cube root? You cube the 2 to bring it inside. You're going to cube the 2. So, what is 2 cubed? 8. Hey, how did you remember that? Right, and it helps, hey? It really helps once you memorize those cubes. I promise you, this is where it's going to be so helpful. You're going to be super fast. Like a canceled, yes, sports performance. Okay, do you think the same rules apply? Yeah, it does, as long as the index is the same. As long as they have the same index. So we can put this under 1 radical. What is 8 times 5? You should know that one. 40. 40. Root 40. Now, how can I check my answer? Okay, so type in cube root 40. So where's the cube root? Math 4. So cube root of 40 should be the same thing as 2 math 4. So 2 cube root of 5. And there. Yay. Get it right. Okay. Turn the page. It's almost done. It's a really short lesson today, which is in contrast to yesterday.
Because we ran out of time.
That's a good question. Yeah, maybe we should have. That's okay. Well, okay, to order radicals without a calculator. So if you were to order them without a calculator, we have to convert to entire radicals. So convert it to our entire radical, and then you can order them. Right, because it's easy to order if they're entire. You can easily see which one's bigger than who. With a calculator, how would you do that? The math? Just plug it in, yeah. Get it your decimal. The decimal approximate. Okay? Just type it in. Well, that's the easiest way. So if you had a test question, it's multiple choice and asked you to order, easiest way would just be type them in, see what they are as decimals. Okay, so the first question we're going to do without a calculator. Without a calculator. So we want to convert these all to entire radicals. All of them, including 5. How do we write 5 as an entire radical? Yeah, you got it, Robin. Square root of 25. Yeah, we just square it to put it underneath a radical. Why not? Without your calculator? Absolutely. I know, but you guys, the numbers are small. We can deal with this. Okay, how do we bring 4 into this radical? What will it become? 4 squared is root 16 times root 2, which is root 32. Yeah? We need to wait till after lesson, okay? 2 root 6. How do you bring the 2 inside? 2 times 2 is root 4 times root 6, or 4 times 6, root 24. And the last one is 3 root 3. So we don't need a calculator, guys. Okay, what's 3 squared? 9. So root 9 times root 3. What's 9 times 3? Root 27. Be smart. Okay, so ordering to small. So we are going to least to greatest. Who's the smallest? The 24. So we're going to write the original form. 2 root 6. Then after 24 is 25, so the 5. Then 27, 3 root 3, and then, oh, I'm sorry. And the largest is root 32, so 4 root 2. Okay, I'd like you to try this next one on your own without a calculator, unless you're desperate. So, because root 9 is equivalent to 3, right? So root 9 is the same thing as 3. So we square the 3. Square that first number. 3 squared.
Okay, here we go.
Okay, so that gives us root 9 times root 5. Because square root of 9 is the same thing as 3.
Oh, I see what you're saying.
9 times 5 is?
Because they both have to be in square root 4.
Right. Exactly. And we know square root of 9 is equal to 3. They're equivalent. This one already is good to go, so you didn't have to change him. So what is square root of what gives you 2? Square root of 4. You square the 2. So root 4 times root 7. 4 times 7.
28.
28. Okay, square root of what gives you 4? 16. 4 squared is 16.
We already saw this last time.
And 32. Okay, so smallest one available is 2 root 7. Next smallest, the 28. We got. Then
Square root of 31.
square root of 31. Then
4 square root
4 root 2.
of 2.
Then
3 square root
3 root
of 5.
5. Easy? Now that you get it? Okay, without a calculator, we're just going to type these in. So how do you type in 2? Oh, yeah, with a calculator. Isn't that what I said? Oh, with a calculator. Yeah.
We're going to type this in without the calculator.
Oh, I honestly thought I said with, but then it came out without. All right, boys. You good? So how do you type in 2 cubic root 5? 2 math 4 5 gives us 3.42 approximately. Me? Oh, like 4 decimals. My sister memorized 100 decimals. Yeah, I really didn't have the drive to. I just feel like I have other things to do with my time. I don't know. Okay, so type these in, guys. Order them from, I'm going to let you finish it, from least to greatest. I did 2 of them. Yeah.
So don't punch it. Don't break your calculator using
Did you need? Sorry, Sam. Here. You can use this. A new one, okay? Sorry. I should have gave you that. 7. Okay. I know. Yeah. Well, just like talking about perfect squares and perfect cubes is kind of the intro to this, but. All right, so you should have got those decimals. Did you get the same ones? So from least to greatest at cubic root 13, then 2 cube root 5, then what's next? 6 cubic root 3, 7 cubic root 2. Okay, there's 2 things for homework. Yeah, worksheet. What page is that in your next page? Page 62. Okay, so there's that worksheet in your workbook, in your notes, page 62. So it's on the next page. There's some square roots and cube roots. And then also page 218, okay? So if you finish early, make sure you work on your study sheet, and then we're going to have a quiz with 15 minutes left in class. So in about 30, 35 minutes from now, 40 minutes. The quiz from yesterday that we didn't do at the beginning of class today, we're going to do at the end of class. Yesterday's lesson. Yeah, just because if you needed to work on some of yesterday's lesson or just review, write down a study sheet, I thought I'd give you time for that today. Okay?